Right, class, we're going to be working on the goodness of fit test that we're going to be doing. So if you can turn to this page in your notes and we'll do it together. I don't actually have my notes with me, so I've got it up on my screen and then I'm going to do it on file paper and you can fill it in with me. Okay, so the first part of the question, it says state the value of P, and you've got this distribution here and they've given you the probabilities of this discrete distribution. And you should know that all these probabilities need to add up to 1. So to work out this missing value, you just do 1, take off all these values here. So to work that out is quite easy. Working it out, that would give you 0.075. So I'm just going to write that down, that my p-value there is 0.075. Okay. Now, we've got this distribution. We think that this is the model, essentially. But what actually happened, what we observed when we did this test, whatever it was, it could have been a 5-sided die, not sure what it was, but these were the values that we actually observed. And if you add up all these frequencies here, you'd get total, and the total here is 60, okay? And what we're going to do is we're going to look at, well, if this observed pattern fits this distribution, what would we have expected for our frequencies here? So to work out these frequencies, so for example, if I've got that I do this test 60 times and I expect 1 to come up 0.25 times. Okay, so if I do 60 times 0.25, 0.25, you would get that is 15. So my first expected value is 15. Okay, 15 there. And then I do the same for that. I do 60 times 0.3. I stick that value there. I do 60 times 0.25. I stick that value there. 60 times 0.15 and 60 times 0.075. So you'd work out your expected frequencies. So if you've worked them out, you would get that you would expect to get 18 for 2. You'd expect 2 to come up 18 times. 60 times 0.25 is 15 again. 60 times 0.15, that's 9. And 60 times 0.075, you would get 3. Okay. Whenever you're doing a goodness of fit test, which is essentially what we're doing here, if you get any expected frequencies which are lower than 5, like I've got here, I've got this expected frequency of 3, then what you have to do is you've got to combine it with a frequency close by. Okay, so what I'm going to do is I'm going to combine these two frequencies here. So that there is 16. This here gives me 12. Okay, and then we'd have to work out our degrees of freedom. Now the degrees of freedom is always n minus 1. So here we've got 1, 2, 3. We would have had 5, but because I've combined these two, we've actually got 1, 2, 3, 4 that we're looking at. So n here is 4. And my degrees of freedom here will be 4 take away 1, which in this case is 3. Okay. And then what we're testing to see whether the observed values match this distribution here. Okay. So what we do, we assume that it does match that distribution. And we say the observed distribution can be modelled by the distribution in table 1. So I'm just going to write that down. The observed distribution is modelled by the distribution in table 1. Okay. And the alternative hypothesis is that the observed distribution cannot be modelled by table 1. Okay, so H1, the observed distribution cannot be modelled by table 1. Table 1. Okay, so you always have to define your H0 and H1. Okay, so then we want to see how closely the observed data matches the expected data. And we use this formula here, this formula here is the sum of the observed minus the expected squared divided by the expected value. Okay, so here what I'm going to do is, if I look at my first scenario, my observed is a 9, my expected is 15. So I do 9 take away 15. I'm going to square that, and I'm going to divide it by the expected value, 15. Okay, and then, because it says sum, I'm going to add it to the next observed minus expected squared divided by expected. So here I'd be 18 minus 15 squared all over, have I done that the wrong way around? 15 minus 18. It doesn't really matter here because I am squaring it, but I will write it the right way around. 15 take away 18 squared divided by the value that's expected. Okay, I do the same for the next one, plus observed 20, expected 15. So I do 20 take away 15 squared all over expected, plus, and then my final observed is 16, expected is 12. Remember, I combined these two here. So 16 take 12 squared, divided it by the expected value. And you just work it out on your calculator. And if I work that out, I get 5.9. Okay. And let's say this particular test, I think we're doing it at the 5% level. So if you go back to the question and read it, it says test at the 5% level where the probability distribution is matching the model that we were given in table 1. Okay, so at the 5% level, so I need to go to my table. So I'm looking at 5% level. And if you've got your formula booklet, you'd look at your formula booklet. If you don't, you can go to the Further Stats 1 book, which is on Active Learn. And I'm looking at page 192 because I don't have my formula booklet. And we're looking for the percentage points of its chi-square distribution. Okay. Now this letter here, V, that's your degrees of freedom. Okay. And this here is your significance level. All right. So my degrees of freedom is 3. Okay. And my significance level is 5%. So I'm going to go across to 5%, which is 0.05. There it is. So that's my critical value, 7.815. I'm just going to write that down. So I'm going to write critical value. I'm just going to squeeze it on here. Critical value is the chi, see how we write that? So chi-squared, degrees of freedom is 3. And I've looked it up and it's 7.815. Okay. Now, in terms of the distribution for the chi-square distribution, it looks something like that. The value I got was 5.9. Okay, so I've got that my critical value is 7.815. So this here is my critical region. Okay, the shaded bit is my critical region. Any value that 7.815 or more is a critical value. Okay, or is inside the critical region. The value I got was 5.9. Which is not inside the critical region, which means that it's not significant. Okay, so I'm going to write not significant. I'm going to try and squeeze it on here. Not significant. So that means we don't reject H naught. Okay, we say do not reject H naught. I'm just going to try and squeeze it on. There is not or insufficient evidence to support the claim that the observed distribution cannot be modelled by the distribution in table 1. Okay, so I'm kind of running out of space, so you'd have to write that yourself. There is insufficient evidence to support the claim that the observed data cannot be modelled by the distribution in table 1. Okay,